In this lesson, we're going to cover the composition of functions. So we'll start with this definition. If we're given two functions f of x and g of x, in which the domain of f contains the range of g, then we define the composition function, this right here, this is our composition function f composed with g, to be the function f composed with g of x equals f of g of x. So quite simply, if we're given a function f of x and a function g of x, all we do is replace this x with whatever g is equal to. So we just plug the g right in here for that x, and that's our composition function f composed with g. Now this concept is very useful in calculus because, as we'll see, we'll use this concept to employ what's called the chain rule. And the chain rule is used to differentiate rather complicated looking functions. And so we'll use this concept in the chain rule later on. So let's take a look at this example. So if we're given the function f of x equals 1 over x and g of x equals x squared plus 5x plus 10, let's evaluate f composed with g and then g composed with f. And we'll see if they're equal also. So beginning with f composed with g, well, that by our definition is f of g of x. Now remember, when we evaluate f of anything that's inside the parentheses here, we put back in place of the x right here in our definition for f of x. So this is going to be 1 over g of x. And the g now is equal to x squared plus 5x plus 10, so we put that in place of the g. And here is our composition function f composed with g. Now let's look at g composed with f. So by definition, this is going to be g of f of x. Now, wherever we see an x up here in our definition for g, we replace it with the letter f. So this is going to equal like that. And now we replace the f with 1 over x. So this is going to be 1 over x, the quantity squared, which I'll just write like this. Right, that is the same as, just to make sure we understand this point. Right, that's the same as this. So here's f squared. I'll leave it like that. Plus 5 times 1 over x. Plus 10. And we could simplify that as, and there we go, there is g composed with f. Now notice that these two functions are not equal to each other. This is not the same as this down here, so these are not equal to each other. So in general, that's normally going to be true. F composed with g will not equal g composed with f. So we don't have a commutative property there. We can't just flip the f and g around and get the same thing back. They usually will be different. Let's take a look at this example. If we're given the function h of x equals the sine of x cubed plus x plus 1, let's find two basic functions f of x and g of x in which h is equal to the composition f composed with g. Well, we can pretty easily see here that if we pick what's inside here to be our g of x, and we pick our sine to be our function f of x, then we see that this will be f of g of x. Let's just verify that. So if we pick f of x to be the sine function, and we pick g of x to be the function inside the parentheses up here, then when we evaluate f of g of x, So this is our composition function. That will equal the sign of g of x. We put this g in place of the x right here. And then this is just, and that's what we wanted. So we see if we're given this function here, if we pick the g to be what's inside the parentheses and the f to be what's outside, then f composed with g will give us back our original function. So now we've written this as the composition of two basic functions. So let me say that again. We've taken this complicated looking function and written it as the composition of two more basic functions, a sine function and a polynomial. And that's a very important concept when we study the chain rule in calculus. Let's take a look at one more example. So this is a similar problem, but now we're given the function the square root of the tangent of x cubed plus 1, and now we want to write this as the composition of three functions, f, g, and h. So you see we want to write the function k as f of g of h of x, or f composed with g composed with h of x. So what should we pick for our f of x? What should we pick for our g of x? And what should we pick for our h of x? Well, going back up here, for the first function here, reading from right to left, you usually want to pick the innermost function of x right here. So we're going to pick our h to be x cubed plus x plus 1. Then for the next one, we're going to pick the tangent. So we'll pick the g to be the tangent. And then notice if we do this, g of h will be the tangent of x cubed plus x plus 1. So this term right here will be g composed with h. Now what should we pick for the f of x? Well, the very outermost function, which is going to be the square root function. And now let's just verify all of this. So if we evaluate f composed with g composed with h of x, this is going to be f of g of h of x. And this will equal, now the f is the square root, so this will be the square root of g of h of x. And g is the tangent, and h is x cubed plus x plus 1. And so this will be, and so there. So by doing this, we took a rather complicated looking function and wrote it as the composition of three basic functions: a square root of x, a basic trig function, and a simple polynomial. And once again, that's going to be an important concept to understand how to do when we study the chain rule for differentiating complicated functions like this.